You look up at the sky and see a giant fireball. Since you were a kid, you've been taught one unbreakable rule of fire. It needs three things to exist: heat, fuel, and oxygen. Take away the oxygen, and the flame chokes and dies instantly. That's simple, perfect logic, and it governs our little planet Earth just fine. But then you look up at that blinding, brilliant disk that dominates our solar system. Our sun sits there, warming your face, burning fiercely in the absolute void of outer space. And this is where your common sense completely falls apart. Space is a total vacuum, a silent, frozen emptiness with no air, no atmosphere, not a single molecule of oxygen to breathe. Nothing at all. So if space is this vast, empty ocean, how is it possible that the sun has been burning for over 4 billion years without going out? The answer most people accept is frankly naive. They think it's just a giant ball of fire floating in space. I'm here to tell you that your own eyes are lying to you. The sun is not burning. There isn't a single spark of classical fire up there. What you're witnessing every single day isn't combustion. It's something far more violent, far more bizarre, and honestly, far more terrifying. Today, I'm going to tear apart that childish image. I'm going to take you straight to the exact center of this monster, 15 million degrees Celsius, so you understand what's really happening when the universe decides to crush matter itself. Forget fire. This is a continuous subatomic massacre. Listen carefully. To understand the fraud behind the idea of a sun on fire, we first need to break down the lie of what you call fire. Do you think you know what it is? You strike a match, you see the orange flame, you feel the heat, and your primitive brain settles for that image. But I'm not primitive. And if you're listening to me, you shouldn't be either. What's actually happening in that match? It's pure chemistry, predictable, and honestly, pretty boring. You have atoms, you have molecules. In the wood, you have carbon and hydrogen tightly bonded together. When you strike the match, friction generates initial heat. That heat excites the molecules. And this is where our famous oxygen comes in, the great dictator of combustion on Earth. The oxygen in our air is incredibly reactive. It's a cosmic parasite, a thief that steals electrons. When there's enough heat, oxygen rushes in and attacks the carbon and hydrogen in the wood, breaks their bonds, and forms new molecules, mainly carbon dioxide and water vapor. In this exact process of breaking apart and rebuilding, leftover energy gets released. That leftover energy travels to your eyes as light and to your skin as heat. That's your sacred fire. A simple dance of electrons, a surface-level rearrangement at the outer edge of atoms. The nucleus of the atom doesn't even notice this is happening. It's exactly like repainting the outside of a house while the concrete foundation stays completely untouched. Now take that idea of chemical fire and throw it in the trash, because on the scale of the universe, it's completely useless. Imagine we built a massive spaceship as big as planet Earth itself. We fill it entirely with the driest, most perfect wood imaginable. We haul it into the vacuum of space, get close to the sun's orbit, and try to light it with a detonator. What would happen? Absolutely nothing. Not a single spark. Without that electron thief called oxygen, the wood would just float there, inert, dark, and pathetic. So here's the key question. If the sun were just a giant ball of wood or coal, burning in the conventional way, and we somehow magically pumped in all the oxygen needed to keep that chemical reaction going, how long do you think it would stay lit? Take a guess. 1,000 years? 1,000,000? I worked this out myself a long time ago, based on the massive amount of energy the sun pours into space every single second. If it were made of the best coal in the universe and had unlimited oxygen, it would burn itself out completely in less than 5,000 years. 5,000 sad little years. And yet, we know without a shadow of a doubt that the Earth is over 4 billion years old and the sun has been blazing away the entire time. Grade school chemistry is mathematically incapable of explaining the sun. The numbers simply don't add up. Chemical fire is a joke compared to the real cosmic beast. So we throw out fire, we throw out coal, we throw out oxygen, and we face the cold hard facts. The sun is actually an immense, almost incomprehensible sphere of gas, mostly hydrogen, the simplest and lightest element in all of creation. One proton at the center, one electron orbiting it, with a bit of helium mixed in. But this isn't just any cloud of gas, it's astronomically heavy. The sun makes up 99.8% of all the mass in our entire solar system. Jupiter, Saturn's rings, Earth, the oceans, you and me, all of it combined is statistically irrelevant. It's basically all sun. And here's where the mystery begins. A normal cloud of hydrogen floating in space just cools down and disperses into the vacuum. It doesn't glow. You could fill the entire universe with hydrogen and have a completely dead universe. For that ball of gas to shine with enough fury to cross 150 million kilometers and burn your skin, we need a force that overpowers the fundamental laws of repulsion. We need to go down to the core. I told you a moment ago that the sun holds almost all the mass in our cosmic neighborhood. But mass isn't just some lazy number, not just space being taken up. Mass dictates the most unstoppable force in the universe, gravity. Picture, for a second, the sun as a structure desperately trying to collapse in on itself. The outer layers, thousands and thousands of kilometers of heavy gas, fall toward the center, dragged down by their own colossal weight. On Earth, gravity barely keeps your feet on the ground. In the sun, the crushing weight of trillions of tons of hydrogen, all pushing toward a single central point, creates a prison of pressure beyond description. And what does the strictest thermodynamics tell us? When you compress a gas with brutal force, the gas fights back, it heats up. It's the same reason a bicycle pump gets hot when you inflate a tire, except scaled up to a level of absolute insanity. Picture the exact center of this monster. The pressure there is roughly 260 billion times greater than the atmospheric pressure you're feeling right now in your room. Under that extreme physical torture, hydrogen transforms. Forget the gaseous state entirely. The heat is so savage, reaching 15 million degrees Celsius, that atoms literally get torn apart. Electrons that normally orbit nuclei like peaceful little planets get violently ripped away. What's left in that boiling core isn't gas anymore, it's plasma. A dense, murky, furious soup where naked protons, the nuclei of hydrogen atoms, shoot in every direction at ridiculous speeds. And this is exactly where classical physics breaks its neck. This is where a mystery so dark emerges that it kept early 20th century astronomers awake for decades. All those naked protons flying around in the plasma carry a positive electric charge. And if you've ever taken two magnets, tried to push the matching poles together, you know exactly what I'm talking about. You feel that invisible resistance, like pushing against an indestructible rubber wall. They repel each other. It's an unbreakable law of electromagnetism. At the subatomic level, that repulsive force between two positive charges is terrifyingly powerful. For the sun to ignite its reactor, to produce the light that keeps this insignificant little planet alive, those protons have to collide and fuse. They have to actually touch, but the electromagnetic force screams that this is forbidden. It builds an invisible wall of energy around every single proton. The physicists of that era ran the numbers, and I've gone back and checked them myself more than once. For two protons to slam into each other hard enough to break through that invisible wall and fuse together, they need to be moving at insane speeds. They need extreme heat. But the numbers reveal something horrifying. 15 million degrees Celsius sounds like a lot, but mathematically, it isn't even close to enough. According to the rules of classical physics, the sun's core is too cold. Did you hear that right? Too cold. The protons simply don't have the kinetic energy needed to overcome electromagnetic repulsion. Every time they're about to collide, the repulsion bounces them back, unharmed. Under Newton's physics and traditional thermodynamics, that fusion never happens. The sun shouldn't be able to generate energy. The sun should be a massive, black, lifeless ball floating in a completely frozen, dead universe. You shouldn't exist. I shouldn't be talking to you right now. None of this should be real. But you look out the window, and there it is, dazzling and defiant, mocking classical math every single day. If you think this is just a calculation error, that science has somehow failed to give you real answers, it's because your mind is still trapped in conventional thinking. For the sun to exist, the universe has to cheat. A proton has to run into that impenetrable electromagnetic wall, realize it doesn't have the energy to climb over it, and simply pass through it like a ghost. I left you facing an impassable wall, an invisible barrier of electromagnetic force. I want you to fully grasp the scale of this impossibility before I reveal how the universe decides to break its own rules. Imagine you're standing at the base of a massive, steep mountain. In your hand, you're holding a heavy steel ball. Your only goal is to push that ball uphill with enough force that it crosses over the peak and rolls down the other side. If you push weakly, it will climb a few meters, lose momentum, stop, and roll back down, crushing you on the way. The peak of that mountain represents nuclear fusion. Is the exact point where the strong nuclear force kicks in. This is the most powerful and lethal force in the universe, but it has a pathetically short range. It only works if the protons are actually touching. If you manage to get two protons over that peak and close enough together, this force snaps shut on them like a bear trap and fuses them permanently, releasing the colossal energy that lights up the entire solar system. But the slope of that mountain, that endless incline you have to push the ball up, is electromagnetic repulsion. As I said before, positive charges hate each other. Every millimeter you try to push one proton closer to another, the mountain gets steeper and steeper. That invisible force pushing them apart grows exponentially, brutally. To get the ball over the peak so the strong nuclear force can grab it, you need a massive push from the bottom. In the sun's core, that push is temperature. 15 million degrees Celsius sounds like a furious apocalyptic inferno. I know. But to the tyranny of particle physics, it's barely a mild day. I've gone over these calculations countless times. The brightest physicists of the early 20th century, like Arthur Eddington, looked at these exact numbers and stared into a terrifying abyss. According to classical thermodynamics, the temperature of the solar core only gives our steel ball enough energy to climb a measly 1% of the mountain slope. It doesn't even come close to the peak. It bounces back again and again and again. For billions of years, you'd have trillions of protons blindly colliding and bouncing back with absolutely nothing fusing. Zero energy produced, zero light, zero heat. That's the real paradox. The sun is right there, blinding your eyes if you dare to look at it, sustaining life on an entire planet. But the unyielding mathematics of Isaac Newton and James Clerk Maxwell swear on their honor that this glow is completely impossible. We were facing a monstrous dilemma. Either our measurements of the sun's size and temperature were catastrophically wrong, or the fundamental laws of reality, the very fabric of what we consider true physics, were deeply broken. And let me tell you something about the universe. The universe is never wrong. We're the ones who cling to stupid ideas. The mistake wasn't in the sun. The mistake was in the human brain. It was our deep, stubborn insistence on believing that a proton is a small, solid billiard ball. For as long as you can remember, you've interacted with solid objects. You touch a table, throw a rock, drive a car. Your brain is wired by millions of years of evolution to understand matter as something with defined edges, with an exact, absolute position in space. If I ask you where your house keys are, you give me a precise location. They're on the table or they're not. There's no in between. That's the comforting lie evolution told you so you could survive out in nature. But when you descend into the subatomic slaughterhouse of the solar core, that human intuition becomes garbage. I need you to abandon, right now, the idea that a proton is a solid object. If you keep picturing little balls bouncing off each other, you'll never understand why you're alive today. To solve the paradox of the sun, we had to accept a theory so absurd, so sickeningly contrary to human logic, that even brilliant minds like Albert Einstein bitterly struggled to digest it. We had to accept that at the most intimate scale of reality, matter is an illusion. I said, matter is an illusion. I demanded you stop thinking of a proton as a solid, unbreakable billiard ball. Now let me explain exactly why. In the early 20th century, physicists like myself were forced to accept quantum mechanics. Not because we wanted to trust me. Nobody in their right mind liked the idea at first. We accepted it because it was the only math that didn't completely collapse when we observed the microscopic universe. In the quantum realm, a proton doesn't have a defined edge. It isn't sitting in one absolute spot like a rock on the ground. A proton is actually a cloud of probabilities. It's a blurry, trembling wave that mathematically describes where it might be if the universe were forced to pin it down to a position. Imagine taking a photo of a spinning fan blade at full speed. You don't see solid blades, you see a blurry disk, a smear where the blades exist almost everywhere within that circle at once. That's exactly how matter behaves in the violent center of the sun. Remember that electromagnetic mountain from the last section? That huge invisible wall of repulsion the protons didn't have the temperature or energy to climb? In basic classical physics, the steel ball climbs a little way up the slope, hits the mountain wall, and always bounces back. But now we know the empirical truth. The proton isn't a steel ball, it's that blurry fog of cosmic probability. When this probability wave hits the massive wall of electromagnetic energy, something happens that should completely stop your rational brain in its tracks. Most of the wave bounces back, of course, but the mathematical equation of that wave doesn't end abruptly at the wall, it fades gradually. And this means a tiny fraction of that probability wave literally leaks through and exists on the other side of the wall. Let me translate this into your everyday reality so you understand the sheer monstrosity of what I'm telling you. Imagine I lock you in a cell with steel walls 5 meters thick. You have no tools. If you run and slam into the wall, you'll break your bones. Try it 1,000,000 times, and you'll die crushed against it. But if you were a quantum proton, physics says that if you slam into that wall enough times, on one of those sporadic attempts, you won't collide at all. You'll simply vanish from this side of the cell and instantly reappear on the other side of the steel wall, completely intact, no hole, no breaking through, passing through solid matter like an absolute ghost. We call this brutal piece of logic quantum tunneling. It's not magic, it's not some science fiction trick for weak minds. It's the most rigorous, most proven fundamental law of our reality. This quantum tunneling effect is the one and only reason you're not frozen in the darkness of space right this instant. In the sun's core, at 15 million degrees Celsius, protons are slamming into each other with fury. They don't have the thermal energy to overcome repulsion. But because they're probability waves, an incredibly tiny fraction of them manage to pass through the electromagnetic wall purely through tunneling. They magically appear close enough to each other that the inescapable trap of the strong nuclear force snaps shut. They fuse, pure energy is released, and the sun shines. But I need to warn you about one last thing before we move on. The odds of a single proton successfully tunneling through are so pathetically low, they're practically zero. A single proton in the sun's core can spend billions of years colliding and bouncing back before it manages to tunnel through even once. It's mathematically worse than winning the lottery every single day for an entire century straight. So if the probability is almost zero, we run into a massive new problem. How on earth does the sun manage to generate such a constant, scorching amount of energy enough to keep us alive hundreds of millions of kilometers away? Well, the answer reveals the true, incomprehensible scale of the monster orbiting Earth. I told you the odds of a single proton tunneling through that wall are practically nil, a winning lottery ticket in an ocean of trillions of losing ones. If you and I were in charge of designing a power plant and used this method, we'd be fired for being idiots. It's the most inefficient, random, pathetic process you could possibly imagine for generating energy. So we run into the brutal empirical reality. The sun does shine. It warms your face every morning. How do we reconcile a probability that's basically zero with the constant fury we see in the sky? The answer is scale. The problem isn't the universe. The problem is that your primate brain is pathetic at processing truly large numbers. Your brain evolved to count fruit on trees or rainy days, not to comprehend infinity. You think $1 million is a colossal number? You think a billion stars represents vastness itself? I'm about to crush that perception right now. The sun doesn't have 1 billion protons. It doesn't have 1 trillion. The number of protons packed and crushed in the core of our star is roughly a 1 followed by 57 zeros. That's such an obscenely vast quantity that human words completely fail to describe it. When you have that monstrous amount of quantum matter churning, boiling at 15 million degrees, with protons colliding billions of times every fraction of a millisecond, low quantum probability stops being an obstacle. The universe doesn't need tunneling to be easy. It just needs to roll the dice enough times. If you roll a quantum die a quadrillion times per second, the statistical miracle stops being a miracle. It becomes a brutal, inevitable mathematical certainty. Pure statistical brute force forces the sun to shine. But here's where the real thermodynamic irony is going to shatter everything you thought you knew. Listen closely, because this goes against everything you've been led to believe about our star. You look at the sun and see absolute fury. You think it's the most efficient, ravenous, perfect furnace in the universe. That's a ridiculous lie. Because quantum tunneling is so desperately rare, the overwhelming majority of the solar core is doing absolutely nothing productive. Those protons are just colliding and bouncing around uselessly, like flies trapped against a window. If you could scoop out 1 cubic meter of the sun's core, say, a cube the size of a kitchen refrigerator, and measure exactly how much energy it's generating through quantum fusion, you'd be in for the biggest disappointment of your life. That cubic meter of stellar material sitting at the center of our glorious star generates less energy than a pile of rotting leaves composting in your backyard. It produces less heat than a cold-blooded reptile lying motionless on a rock. Check the math yourself if you're capable of it. The power density of the solar core is pathetically low. As an engine, the sun is genuine garbage. So if it's this inefficient, why does it blind you? Why does it dominate our entire solar system? Because there isn't just 1 cubic meter, there are billions upon billions of cubic kilometers of this slow, clumsy machine. The sum total of that quantum mediocrity, multiplied by the sheer immensity of the sun's volume, is what creates the overwhelming energy that sustains the Earth. And you should be on your knees thanking that inefficiency. If quantum tunneling were even 1% easier, if that electromagnetic barrier were just slightly weaker, the chain reaction would be devastating. The sun would have burned through all its fuel in a catastrophic explosion billions of years ago. We wouldn't exist. That quantum error ends in fusion. Pure energy is created. A photon of light is born deep within the core, ready to illuminate the universe. Do you think that photon just travels in a straight line out into space and reaches your eyes? Wrong again. What awaits that ray of light is unimaginable torture. Basic logic from your earthbound brain would tell you this little particle of light has one destination: travel freely outward. After all, you've been told 1,000 times that light is the fastest thing in the entire universe, moving through the vacuum at roughly 300,000 kilometers per second. From the exact center of the sun to its visible surface is a straight line distance of about 700,000 kilometers. Do the simple math, the kind you teach a small child, divide that distance by light's maximum speed, and you'd smugly conclude that this newborn photon takes just over 2 seconds to escape the star and shoot out into the cosmos. 2 measly seconds. That's what common sense dictates. And once again, the universe laughs in the face of your common sense. That photon isn't escaping in 2 seconds. It's about to live through an absolute hell of captivity lasting, on average, around 100,000 years. Picture the crushing density of that stellar core. You're not dealing with air, not ocean water, not solid rock. It's boiling plasma compressed under trillions and trillions of tons of crushing gravity, a subatomic maze so unbelievably dense that it's physically impossible for anything, even light, to travel in a straight line. Our newborn photon, which at this point isn't visible light, but a lethal, ultra-energetic gamma ray, starts its journey at the maximum speed reality allows, and within a tiny fraction of a millimeter, it slams with incalculable violence into a wandering proton or helium nucleus in that thick soup. In that exact impact, the particle of light dies, ceases to exist, completely absorbed by matter. But the relentless laws of thermodynamics demand instant balance. That particle of matter, now holding too much internal energy, becomes unstable, and in a microscopic instant, spits out a new photon to shed the excess. But here's the mathematical curse that seals the sun's fate. The new photon doesn't shoot off in the same direction as the old one. It gets ejected at a completely random angle. It might go up, sideways, or, statistically worse, straight back toward the very core it was desperately trying to escape. This new photon travels another microscopic millimeter at light speed, slams into another wall of plasma, gets annihilated again, and gets spat out again in a random direction. We call this tortured pattern of chaos the random walk, or the drunkard's walk problem. Imagine blindfolding a man, spinning him until he loses all sense of up and down, and telling him to walk in a straight line out of a massive cave packed with closely spaced columns. He takes a quick step, smashes face first into a column, bounces back, completely disoriented, steps right, smashes again. Now multiply that cave by the colossal size of our star. That's the quantum purgatory our photon faces. Trillions upon trillions of brutal collisions, absorptions, and dark re-emissions. Every miserable centimeter gained toward the sun's surface is paid for dearly with millions of wasted steps in the wrong direction. In each of these brutal collisions, across those 100,000 years, the photon loses a tiny fraction of its original strength. That deadly gamma ray, capable of instantly destroying DNA chains, weakens, stretching its wavelength. It becomes X-ray light, then ultraviolet light, wearing down millennium after millennium in its blind struggle to escape the gravitational maze.